Hello and welcome to our regular yearly What's New in Julia for Visual Studio Code talk. This is a joint talk by Sebastian and myself, and I'm David. Before we jump into the new features that we added to the extension in the last year, I just want to thank all the other people, and there are many of them, who contributed pull requests, feedback, opened issues, and helped us improve the extension and make it what it is today. So thanks a lot to everyone. And with that, let's just start with our first new feature, and Sebastian is going to demo some new features in the table viewer.
So let's just load a bunch of small data sets and generate two synthetic data sets, one medium-sized and one fairly large matrix. All of those can be represented in the integrated table viewer by just going to the Julia panel on the side here, and in the workspace, all variables we've defined show up. You can just click on iris to take a look at how the data frame is implemented, but that's not very interesting, right? So this button on the right here will take you to the table viewer. Let's just drag that over here. And you can see that all 150 rows are in here. You can sort by, I don't know, petal length or by petal width. You can filter. For example, this is a string column, so we can set a contains filter for Setosa. And that cuts a number of rows into a third. We can add another filter for the petal width, let's say, and we only want those rows with the petal width less than 0.3 and a petal length greater than 1.4. Okay, so this is very easy to do for small data sets. Neuro and this HSB82 dataset are also fairly small. Performance when going through them is very good. Filtering and all of that will work very smoothly. This medium-sized dataset contains 300,000 elements, but will still work fairly well. The difference here is that we don't load all of this data into your browser, into your VS Code instance, and instead query it lazily from the Julia backend, which you can, for example, see when scrolling through here. Sorting and filtering still works, but takes a bit longer. We can still get, all rows where the first column is less than 0.05 or whatever. And that cuts the total row into, a small fraction. For large matrices, this is like this one with 10 million elements. This isn't quite possible. It would be prohibitively slow in this implementation, so for those you just get this unsortable, unfilterable view. But you can still scroll through the end, take a look at all of those 10 million elements if you so desire.
Some of you might know that there's going to be a new way to install Julia on your computer called Juliaup, and during the last year we integrated the extension really tightly with Juliaup. And I'm going to demo that next. If you're also curious what Juliaup is, there's another JuliaCon talk by myself this year, and so I recommend that you watch that one as well. So the new Juliaup integration into VS Code really shows up in two different ways, and I'm going to talk about them in turns. But before I show you this, I just want to show you how my system here is configured. So if I run Juliaup status, you can see that I have 3 channels installed on my system in Juliaup: the release channel, the long-term support channel, and the release candidate channel. So there are 3 Julia versions available on my computer. The release channel is the one that I've configured as my default channel. So the first way this integration now shows up is if I create a new Jupyter notebook here with the create new Jupyter notebook command in Julia VS Code. Then you can see up here on the top right the kernel selection button. And if I click this, it now shows all 3 Juliaup channels that I have installed. So I can decide whether I want to run this notebook with the long-term support channel, the release candidate channel, or the release channel. So let's say I want to use the release candidate channel here. So I've selected that kernel. I can run version info here inside my notebook, and now you can see that I'm running with Julia 1.8. The second way you can use Juliaup is that you can set a per folder or per workspace configuration in VS Code, and then a REPL that you start in that workspace will pick up that Juliaup version. So how do we do this? So first of all, we open the settings in Julia VS Code. Then we switch over to the workspace settings, because those are the settings that are specific to the currently open workspace, not the global user settings. And then I'm going to search for the Julia executable path setting. And what I can put in here is the standard Juliaup version selection command. So I can say Julia plus LTS, for example, if I want to use the long-term support version of Julia inside this workspace. So I've configured this setting now, and if I start a Julia REPL now inside this workspace, then it will pick up that I've configured just for this workspace that I want to use the long-term support version, and that, of course, at this moment is Julia 1.6. Another really exciting new feature is called shell integration, which makes working with the terminal much more pleasant, and Sebastian is going to demo that.
Another pretty exciting feature we've recently added to the extension is shell integration. VS Code has supported shell integration for the latest 2 or 3 releases by now, but it's only enabled by default in the 1.70 release. If you want to double check whether it is enabled for you, then go to settings and search for shell integration, or copy this ID there. You'll see this checkbox and can tick it or untick it as you wish. If it's ticked, then you'll get shell integration in Bash, PowerShell, and Z Shell on Unix systems, or just PowerShell on Windows, and of course in Julia. So if I type a command into the REPL, you'll see this translucent circle here turning blue or red, depending on whether the command that I just ran succeeded or errored. And you'll also get access to a few related commands, like rerunning this command, copying this command, which you then can paste into the editor, for example, copying the output, or copying a rich representation of the output as HTML, which is then supported by editors like Google Docs or Word, where you get all of the styling of this output for free. Now, since VS Code knows where our prompt is and what command we just ran and what its output is, you can also navigate to the previously run command with control cursor up and to the next command with control cursor down. If you prefer to take a look at a list of commands you've recently run in this terminal, then check the run recent command which will allow you to run commands you've run previously, and also to edit them if you, instead of selecting one of those with enter, hold alt and then use that. Now, since the shell is integrated, or Julia in this case, we can also tell VS Code in what current working directory we are. So in this case, the title doesn't tell us anything because we are in the in the VS Code workspace root. But if we change directory to, let's say, this test folder, then we get that in the title. All of these features also work with inline evaluation, at least if you have the setting enabled that echoes outputs and inputs into the REPL. So if I hit Shift-Enter here to evaluate these lines of code, you can see that the appropriate gutter annotations show up. This also works for multi-line commands. Why is this useful, you might ask? Well, if you evaluate something that prints a lot, like this, or just have a very long stack trace, then it's very convenient to just be able to control cursor up to go to the latest command, and then click copy output, for example, and get all of those 1,000 lines of code into my clipboard. You can also more easily navigate to previously run commands because of these annotations in the scroll bar. The same features also work for Bash, C Shell, and PowerShell, as I mentioned previously. So if I run a few commands like these, then you can see that everything works just the same.
During the last year, we switched the formatting backend that the extension uses to JuliaFormatter. And before I demo how that works now, I just want to give a huge thanks to Dom, who created JuliaFormatter in the first place and really helped us integrate everything and make this a really smooth experience. So the way you start formatting of code in Julia VS Code has not changed, even though we use this brand new engine that is much more powerful than what we had before. So I will first demo how that works, and then I'll show you one aspect that has actually changed relative to the previous version. So here I have a file that is horribly misconfigured. So all the indentation is wrong, all the white spacing is wrong. It looks horrendous. If I select it, you can even see that I have white spaces here at the end of lines and all sorts of other horrible things. To format this file, all I have to do is I have to run the format document command from VS Code. And I click that, and immediately the whole file gets reformatted and looks really good. One thing that has changed between our previous implementation and this new JuliaFormatter based implementation is how you configure settings for the formatter. Previously, we used VS Code's settings system for configuring the formatter. We've completely done away with that, and now you configure all formatting settings with configuration files in the workspace. The benefit of that is that the settings that you configure are not only accessible to VS Code, but they're also accessible if you run formatting from a GitHub action or a command line, or if you use the JuliaFormatter package directly. So let me show you how you do that. So in this case here, I'm going to create a new file called JuliaFormatter.toml. That's the name of the configuration file. And then I'm going to say indent by 2 space characters. So now if I open this file 1 again, and I run the formatter again on the whole document, you will see that it reformats everything and now uses only 2 spaces for indentation. One of the nicest new features from this year is our new profiler UI, and Sebastian is going to demo that.
We've also made various improvements to the integrated profile viewer. If you've kept up with the Julia 1.8 release, which is hopefully out by the time you're watching this video, then you'll have noticed that there have been numerous improvements to the normal profiler, as well as the addition of an allocation profiler. So let's just show what those entail. I'm using this profile test function here that profileView.jl uses to show off their flame graph viewer, and we're using the same here to show off ours. This first invocation of @profview and profile test is usually not very interesting because it compiles both the macro and the function, and you're usually not very interested in that if you are just after runtime performance. So let's run this one again. And we get our pretty flame graph viewer here. Unfortunately, a large part of the horizontal space is taken by this wait and pop task function, which is basically just an artifact of the trace containing frames from all threads, but most of those are just not doing anything. They're waiting because this function is single-threaded. So let's just switch to the correct thread here, and you can see that all of the horizontal space is properly taken up by this function invocation here. Oops, this one. You can see by the color of all of these frames that either they're not special, in that case they're blue, or they're orange or red, which includes flags for runtime dispatch, allocations, and so on. If we go back to the trace that contains compilation here, you can also see these gray blocks, which are compilation. So a neat feature we've added recently as well is the ability to save these traces to disk. It's just an HTML file, so I'll save it to profile.html, and you can then just send that file to someone else and have them take a look at whatever profile you've collected. So that's pretty neat overall. All right. This allocation profiler I've been talking about has been added very recently, and you can use the add_profu_allocs macro for it. Let's just take a quick look at the doc string. So it profiles f and shows you the locations in this flame graph. Important keyword arguments are sample rate and whether or not C-frames are going to be included. I'm just using peak flops here because it's a function that's very repeatable and will only allocate a few times. So as before, we're not really interested in the compilation, so let's run it twice. This is the second run already, and you can take a look at what allocations happened in the flame graph as well. So it turns out, yeah, there have been 2, 4, 6, 8, 9 allocations. This is probably a boxed in 64, matrix float 64. Okay, yep. And, well, something. This is useful if you want to take a look at how often Julia allocated anything at all in your function, which usually you want to, get to a very low number. But you might also be interested in how much was allocated. In that case, you can switch from allocation count to allocation size, and the flame graph will look drastically different, of course, because it turns out we're mostly just allocating 2 very big arrays, 32 megabytes each. Once in a fill function call and once in a, matmul function call. As always, you can control click each of these frames to jump to wherever that function was called, and get an estimate of the allocation in here. And of course, these can also be saved as per usual and sent to someone else.
There's some new features that make it easier to evaluate Julia code in Markdown files, and Sebastian is going to show you how that works.
If you're writing a lot of reports in VS Code and use Julia, then you might be interested in the fact that Julia evaluation now works in plain Markdown files, not just in Julia Markdown files. So shortcuts like Alt-Enter to evaluate a cell work just fine. You can also try enabling the Julia execution inline results for cell evaluation settings. So let's just open the settings with Control, paste that ID there, and take that checkbox. If you then evaluate this cell, again with Alt and Enter, then you will get inline results for all lines in here. Also, one new thing is that inline results now support Markdown, so you can actually, take a look at this file again here in the result.
We also got some new features for showing runtime diagnostics that's primarily useful for Jet at this moment, and Sebastian is going to demo that.
The Julia extension already has some limited support for statically computed annotations for example, method call errors, like up here. I've defined the 1-argument function mySum of x and then try to call it with 3 arguments. The linter complains that this might be a method call error because it can't find any definition that actually supports 3 input arguments. If I run this, then I actually end up with this error, as expected. Now, there are certain packages in Julia, like jet.jl. In the past there has been tracer.jl that can use runtime information to actually improve upon this very basic functionality. So let's call jet and ask it if it complains about this function call. We're trying to get the sum of the string Julia, which may or may not work, right? Julia is an iterable. Sum is defined for all iterables, so it might work. Let's see. Okay, turns out that Jet finds 2 possible errors here. We can either take a look at this textual representation or go to the Problems tab, which contains these 2 potential errors. So it turns out that in one code path, Jet doesn't find a definition for plus of 2 characters, and in the other one it doesn't find a method for 0 of the type char. Let's see what happens if we call sum of Julia. We do get method error for plus of char and char. if we take a look at where this happens, then, yep, at sum is defined as x plus y. Turns out that x and y are characters in this case. We can traverse through the call stack for sum and take a look at how this is implemented. The other error happens somewhere in reduce empty, which gives us a hint as to when this other error might happen. Let's just try calling sum of an empty string. And indeed, we end up with this exact same method error. Alright, last thing is that you can clear those runtime diagnostics. For example, if you're working on this file and are annoyed by having the orange squiggly line, you can just use the Julia clear runtime diagnostics command and they will be gone.
The final feature I'm going to demo is a new test runner UI. I have to warn you though, that is very experimental. It's not shipping in the extension right now. There's probably no way for you to try this out because it's in such a fragile state right now. So this is probably going to ship in a few months, but I did want to give you a bit of a peek preview of that. All right, so let me show you how this new test UI and test runner system works. What I have here is a package, a Julia package called string builders. It's a very simple package and it's good as an example. And let's look at our typical run tests file here where we have the tests for this package defined. And by opening this file and looking at it, you can already tell that it is different from what you're used to because we now have put all the tests in these test item macro blocks. So that's a new feature of this implementation here. And a test item is essentially the smallest unit of tests that you can run and individually run. And you'll see in a second what that means. Other than that, the tests look fairly standard. You have some code that runs and then tests for equality here, for example. Now, when you add test items to your project, then you can click on this little test icon here in the VS Code UI. What this does is it looks at all the files in your workspace and extracts and identifies all the test items that you have defined. So for example, here you can see a list of all the files in my project, and then you can see that it identified in the run tests file 2 test items, the basics and the advanced test item. Now note that this test item detection is in real time. So for example, if I just delete one character here, from the code, even without saving anything, this UI now only detects the advanced test item because I have a typo here. If I put the T back in, then the test runner detects this test item again. And now in this UI, I can run either individual test items or I can run all test items, for example, in a given file. So let's start with this. I'm going to run all the tests in the file run tests. They finished, and you can see here that the basics test item passed, but the advanced test item had an error. And we're helpfully taken to the place where the test failed in the UI. We get some error messages here, so we can see that the string evaluated to something that we didn't expect. And all of that is now surfaced in the VS Code UI rather than in a terminal window. So in this case, of course, I introduced a test on purpose so that we have a test failure. So let's go to the actual code for this package. And you can see here we have an error. This code should actually append the string S here. Now note what I'm going to do next. I'm only going to save this file, string builders here. Then I'm going to go back to my testing UI. And now I'm going to rerun only the failed test item that had the problem. So I'm clicking this button here, and the test runner under the hood will pick up the fix that I implemented, and now both of these test items pass. So the idea here is that you get a much more granular way to run tests. You don't have to run all the tests. You can pick and choose individual tests. So that was it with new features from the last year. I hope you like them. Please keep providing us with feedback so that next year we can have another talk and show you some great new additional features, and maybe some of them came from ideas that you provided us with.